Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Let's have Vitamath 50. Two perpendicular chords of a circle are AB 7 cm and BC 24 cm. How far is the right angle corner from the circumcenter? What is the nearest distance of this right angle corner from line AC? In what ratio, long segment over short segment, is the foot of the perpendicular segment from B divide line AC? So let's draw the figure. Take note that if two chords are perpendicular, the longest chord is the diameter of the circumscribing circle, or in other words, it is the hypotenuse of the right triangle because AB and BC are the legs of the right triangle as shown in the figure. So call that AB, then C. AB is 7, one leg, BC is 24, and the right angle corner is B. So the hypotenuse AC, remember by principle, is the diameter of the circumscribing circle, or by sine law, opposite as to sine of angle B, which is sine 90, is 2r. So that's why we conclude that this is 2r, or the diameter. And since it is equal to square root of 24 square plus 7 square, it is 25 cm. The diameter of the circle 2r equals 25 cm. The circumcenter is the center of the circumscribing circle about a triangle. So therefore, the distance from B, which is a point at the periphery of the circle, to the circumcenter, is also the radius of the circle. So O is called the circumcenter. B to O is the distance we're looking for. Distance from the right angle corner B to circumcenter O. And that is R. And R is 1/2 of 25. So R is 1/2 of 25 cm. Therefore, R is 12.5 cm. So R is the distance from the right angle corner, which is point B, from the circumcenter, which is O in this figure. So we have answered the first question. Let's proceed to the second question. What is the nearest distance of this right angle corner to line AC? That nearest distance is the perpendicular segment, line segment from B to AC as shown. And by definition, this H here is the mean proportional between the segments it cuts. So if this segment is X, the other segment 25 minus X, so H square, remember, is equal to X times 25 minus X. But we will not do that in case you forget. So I'll just call this theta because we have two similar triangles, and that's the perpendicular, that's this segment is perpendicular to that, is the foot of the perpendicular line from the right angle corner. And if we call this theta, this angle is also theta here. Let's see. So we have similar triangles. This triangle here, which is small, and this big triangle, original triangle ABC. So we use adjacent of theta to hypotenuse ratio. Adjacent to theta for this small triangle is H. The hypotenuse is 7. And for this big triangle here, the adjacent side is 24 and the hypotenuse is 25. So that is H as to 7 equals 24 over 25. From there, we can now compute H, the nearest distance of this, of the right angle corner to line AC, is H, and H is 7 times 24 over 25, and that is equal to 6.72 cm. Finally, let's answer uh, the last question. In what ratio long segment over short segment is the foot of the perpendicular segment from B divide line AC? So if I call that length or segment X, this other segment would be 25 minus X, and we're looking for the ratio long segment 25 minus X over X. So that's one way. So since we have solved H, actually we can derive H squared, the mean proportional between the segment it cuts. So H square is X times 25 minus X, or H is square root of X times quantity 25 minus X. To derive that, in case you forget, you just use similar triangles. That is H adjacent to theta as to opposite, H as to X. For this triangle here, the adjacent side is 25 minus X and opposite is H. That's why you can form this formula H squared equals X times 25 minus X by similar triangles again. Again, adjacent to theta, H as to opposite X equals adjacent to theta in triangle, this triangle here, BC to the foot of the perpendicular. So 25 minus X as to H. So you can form this. So 6.72 square is equal to 25x minus x square. Rearranging x square minus 25x, then plus 45.1584 equals 0. So using your calculator, there are two roots of x, the smaller one, which is in this case the smaller segment, 1.96 cm, and the longer segment, 23.04 cm. Notice that if the shorter segment is 1.96, 25 minus 1.96 is 23.04, this other value of x. So therefore, we treat this 25 minus x automatically. So the ratio is 23.04, the long segment, over the short segment 1.96. So in decimal, that would be 11.755. The exact fractional value is 576 over 49. Another way of solving for x is by use of similar triangles again. Opposite of theta as to hypotenuse in this small triangle, right triangle, opposite is x, hypotenuse is 7. But for the big triangle, the opposite is 7 and the hypotenuse is 25. So x, another solution, x as to 7 equals 7 as to 25. So x is 49 over 25. That's why the ratio is 25 minus 49 over 25 all over x, which is 49 over 25. So solving for the ratio, ratio is, the exact is 576 over 49, or in decimal 11.755. So that's it. And the answers are the same. So I hope that you increase your knowledge, technique, geometric properties, geometric relations, and hoping that you can use this in your future analysis with geometric figures.